Greetings and welcome to Lesson 2.9, Combinations of Operations and Complex Fractions. Many math problems that you have already encountered are complex. They're more than just multiplication. They're more than just subtraction. So let's work with some mixed numbers and improper fractions with combination of these operations. For example, let's take 5 plus 2.5 times 3 2/3. First thing you want to do when you evaluate a complex problem like this is figure out what operations you need to perform. The first operation is addition and the second is multiplication. Then you need to follow your order of operation rules to be able to get the expected outcome. So addition, multiplication comes first. Now, we need to figure out how to multiply mixed numbers. Well, the first thing we want to do is convert our fractions, our mixed numbers, to improper fractions. So 2.5 will be 2 times 2 plus 1 all over 2. 2 times 2 is 4 plus 1 over 2, so that's 5 halves. And converting 3 2/3 is going to be 3 times 3 plus 2 all over 3. 3 times 3 is 9, plus 2 is 11, so 11 over 3. Now that we have our improper fractions, we can perform our multiplication. So the problem really becomes 5 plus 5 halves times 11/3. All right, addition, multiplication, we do our multiplication first. 5 over 2 times 11 over 3 is really 5 times 11 all over 2 times 3. So that becomes 5 plus 55/6. Now we can add, but to add fractions we need to find same denominator. I can force a 1 look like a 6 by multiplying it by 6, but what I do to the denominator I must do to the numerator. So 5 times 6 is going to be 30, and 1 times 6 is 6. Now I can do the addition. 30 plus 55 all over 6. That's 85 over 6. But I started with mixed numbers, so I should convert back to mixed numbers. 6 goes into 85 14 times with the remainder of 1. So 85/6 is 14 1/6. When you have combinations of operations within a problem, first you got to figure out what you have to do, and in the order in which you need to do it. But you also want to look at it to see, do I need to change these values over, like if they are mixed numbers, do I need to change them over to improper fractions? Or can I use the method of where I add the whole numbers and then add the fractions? So depending on which method you like, either adding the whole numbers and then adding the fractions, or converting over to improper fractions, doing the addition, and possibly changing back, depending on what else we're going to do with this value, it is kind of how you kind of have to have a plan of attack. If you don't have a plan of attack and you're just kind of jumping in head first, you might miss a step or you may do one of the steps out of order. Okay, so let's add within each of the parentheses. Okay. So this problem has parentheses, parentheses, and within the parentheses each has addition. But when the parentheses are together like this, it means that ultimately I'm going to have some multiplication to do. 3/4 plus 5/8, find common denominator. In this case, our common denominator is 8. So for the first fraction, we're going to multiply both the numerator and the denominator, pardon me, by 2, giving us 6/8 plus 5/8, and 6/8 plus 5/8 will equal 11/8. For the second, I'm going to change them over to improper fractions. Knowing that I'm going to have to multiply down the line, I'm going to have to change it anyway, so I'm just going to change it to improper fractions. 2 times 8 plus 3 is going to be 16. 16 plus 3, right? Let me start over again. 2 times 8 plus 3. 2 times 8 plus 3 all over 8. Converting the second. 1 times 4 plus 1. That will give me, for the first fraction, 16 plus 3 all over 8. For the second fraction, 4 plus 1 all over 4. Giving me 19/8 plus 5/4. Now I need to find common denominators. And the common denominator here is going to be an 8. So for the second fraction, I need to multiply both the numerator and the denominator by 2, giving me 19/8 plus 10/8. And 19/8 plus 10/8 is 29/8. Now that I know my first parentheses value and my second parentheses value, now I'm going to multiply them together. In this case, 11/8 times 29/8 is going to be 11 times 29 all over 8 times 8. 11 is a prime number, 29 is a prime number, and therefore I can't reduce. But 11 times 29 is 319. 8 times 8 is 64. But again, my original problem had mixed numbers, so I should convert my 319 over 64 to a mixed number. 64 goes into 319 4 times with the remainder of 63. So my mixed number of 319 over 64 will be 4 and 63/64. All right, let's take a look at another problem. And this one's pretty complex, so I think off to the side I'm just going to write down what I'm going to be faced with and what order I need to do it in. Okay, I have addition, I have multiplication, I have a parenthesis, and inside the parenthesis I have some addition, and then I also have exponent. The first thing I need to do is the parenthesis, and then of course inside the parenthesis the addition. Okay, so now that we've figured out what operations are in this problem, I need to do the parentheses with addition first. And there's a couple of ways of doing it. One is change into improper fractions, but I think for this problem I'm going to just add the whole numbers, add the fractions, and see where it gets me. All right, my whole numbers are 3 and 4, so I'm going to add 3 plus 4. I'm also going to add 2/3 plus 1/3. Well, 3 plus 4 is 7, and 2/3 plus 1/3 is 3/3. But 3/3 is 1. Right? So 7 plus 1 is 8. So my problem becomes 3/5 plus 1/2 times 8 squared. That's the square that was on the outside. It's to the stuff in the parentheses, so it's 8 squared. Now that I'm done with parentheses, I'm left with exponents. 8 squared is 64. I'm done with exponents. 3/5 plus 1/2 times 64. Well, 1/2 times 64, I have to do multiplication first, is 64 halves. Okay, done with multiplication. Now addition. Okay, I'm going to simplify. There's a couple ways of doing it. Find common denominator now and then add like you would and then change it over to mixed numbers. But if we're clever about this, 64 over 2 is 32 times 2 all over 2. The 2's will cancel out, giving me 3/5 plus 32. Now, you can go through the whole thing of finding common denominator and all of that stuff. But what is the definition of a mixed number? It is a whole number plus a fraction. Well, that's the situation we're in. A whole number plus a fraction. Therefore, the answer is 32 and 3/5. In essence, I skipped 2 steps by just kind of being clever about this. First step is finding common denominator, doing the addition, and then the second step is converting that improper fraction back to a mixed number. So just by recognizing that 3/5 plus 32 is the definition of a mixed number, I can jump to saying that it is 32 over 3/5, or 32 and 3/5. All right, let's change gears just a wee bit, and let's talk about complex fractions. Well, complex fraction is a fraction in which the numerator and or the denominator are themselves fractions, or a combination of fractions. Here's a couple of examples. 3/4 all over 5/6, or 3 plus 1/2 all over 2 minus 3/4, or 1/2 plus 2/3 all over 3/4 minus 1/6. Pardon me. So let's take the first problem, 3/4 all over 5/6. Okay. When it's in a situation like this, we talk about the top number, which is the numerator of the complex fraction, and the bottom number, which is the denominator of the complex fractions. So we call it top and bottom, and then for those fractions we keep it as numerator and denominator. All right. Well, the top number is 3/4, the bottom number is 5/6. What we can do at this point is this big fraction bar in the middle is division. So we really have a division problem here. 3/4 divided by 5/6. Now we can use our rules of fractions and division to multiply by the reciprocal of the second fraction. So 3/4 times 5/6. Well, that's going to be 3 times 6 all over 4 times 5. But if I break all of these numbers down into primes, it's really 3 times 2 times 3 and 2 times 2 times 5, and I can see they both have the 2 in common. So I'm going to reduce now, leaving me 3 times 3 on top, on the numerator. It's now a numerator, which is 9, and 2 times 5 is 10. All right, let's go for a little bit bigger problem. 1/2 plus 2/3 all over 3/4 minus 1/6. What I find that's the easiest way to solve a complex fractional problem is to treat the top as an individual problem and treat the bottom as an individual problem. All right, so let's deal with this numerator of our complex fraction. Our numerator of our complex fraction, our top number, is 1/2 plus 2/3. Find common denominator, which will be 6. 2 times 3 is 6, therefore 1 times 3 is 3. 3 times 2 is 6, therefore 2 times 2 is 4. Now I have 3/6 plus 4/6, which is 7/6. So our whole entire top number is 7/6 now. Let's work with our denominator. 3/4 minus 1/6. Find common denominator, which will be 12. 4 times 3 gets me 12, so 3 times 3 gets me 9. 6 times 2 gets me 12, so 1 times 2 gets me 2, and my problem is 9/12 minus 2/12. 9 minus 2 is 7, so my denominator of my complex fraction, my bottom number, is going to be 7/12. Now that I know what the top is and I know what the bottom is, I'm going to bring those together. So my new problem is 7/6 all over 7/12. Again, we're going to treat this fraction bar as division. And we have 7/6 divided by 7/12. Change it to multiplication of the reciprocal, and we can reduce. 7 goes into 7 once, 7 goes into 7 once, 6 goes into 6 once, 6 goes into 12 twice. So really you have 1 times 2 is 2, 1 times 1 is 1, and 2 over 1 is 2. All right, let's work through some problems. Again, I have a complex fraction, 3 plus 1/2 all over 2 minus 3/4. I'm going to treat this as two different problems. Okay, couple ways of looking at this. Because I could be clever and say if a whole number is added to a fraction, that is a mixed number. So here's my first idea. For the top, that is 3 plus 1/2 is 3.5. And because I know I'm going to do some more math on this, I'm going to go ahead and change it to an improper fraction. 3 times 2 plus 1 all over 2 will be 6 plus 1 over 2, and that is 7/2. Let's try the same thing with the bottom number. Okay. 2 minus 3/4 is not the definition of a mixed number, so I can't just jump to the mixed number and change it over to an improper fraction. I need to do this math. So let's find common denominator, because it's really 2 over 1 minus 3/4. My common denominator is going to be a 4. So 1 times 4 will get me 4. Therefore, 2 times 4 is an 8 minus 3/4. And 8 minus 3 all over 4 will be 5/4. Now I'm going to put my two values back together. 7/2 all over 5/4. But we treat this now, this bar, as division. All right, 7/2 divided by 5/4. But we don't do division of fractions. We need to change it to the multiplication of the reciprocal of the second fraction. So 7/2 times 4/5. And I'm going to go ahead and break it down into prime values, prime numbers. 7 times 2 times 2 all over 2 times 5. I'm going to reduce. There's a 2 in the numerator, a 2 in the denominator, leaving me with 7 times 2 is 14. 5 times nothing is just 5, or 5 down in the denominator. And I did start kind of with whole numbers and fractions. Therefore, 14/5 is a solution. And then the second solution is going to be 5 goes into 14 twice, with 4 left over. So if I want it into a mixed number, it's 2 and 4/5. All right, let's tackle another problem. 10 and 1/3 all over 8 and 2/3. Well, I'm going to change each of these into an improper fraction. So for the first one, 10 and 1/3 will be 10 times 3 plus 1 all over 3. 10 times 3 is 30 plus 1 all over 3. So my improper fraction is going to be 31/3. And you might be asking, why am I doing this? Because I really have an addition problem up on top. By definition, a mixed number is the whole number plus the fraction. So my problem has some addition in it. And because of that, I can't do this immediate division. So I have to manipulate it to where I have one value, one number on top, one number on bottom before I can do that last bit of division. Okay? So now that I have changed the 10 and 1/3 to one single number, a fraction is a single number, single point on a number line if you want to think of it like that, I have to do the same thing to the denominator. 8 and 2/3 will be 8 times 3, the whole number times denominator plus the numerator all over the denominator. 8 times 3 is 24 plus 2 all over 3. 24 plus 2 is 26 all over 3. Now that I have my two values, I can bring them together in the fraction. 31/3 all over 26/3. Okay. Ding, 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 trick time. if your denominator in your top number and your denominator in your bottom number of a complex fraction are exactly the same, you can cancel them out and bring the two values together for your answer. Now, why does this work? Here's why it works. If I do this division, it is going to be 31 thirds divided by 26 thirds. Cannot do a division of fractions, so I change it to the reciprocal of the multiplication of the reciprocal. 31 thirds times 3/26. Scooch over a little bit. That will be 31 times 3 all over 3 times 26. The 3's will cancel out. They will do it every single time. So the denominator of the top number and the denominator of the bottom number will eventually cancel out if you do the math. So the trick is, if they're exactly the same, hey, why don't you just cancel them out in the very beginning? Reduce now. Right? And then finally your answer is 31/26. Since I started with mixed numbers, I really should end in mixed numbers. That's going to be 1 with 5/26. There is my final solution. So that's it for this video. Until next time, be seeing you.